From refraction of plane wave using Huygens principle, we will arrive at refraction laws, and that refraction law turns out to be a Snell's law. Resolving power means the ability to produce the distinctly separate images of two closely lying point objects. Each secondary disturbance which originates from these points will spread out in different direction because of which your wave spreads. That is the principle of Huygens. Hello everyone, I am Vrinda, Faculty of Physics, welcoming you all to Chapter 10, and chapter name is Wave Optics, Session 1. In today's chapter, we are studying something more about optics other than your ray optics concepts. So here you have first of all concept called as wave front. Here the optics is studied with respect to the wave nature of the particles. Okay. So first of all, what is wave front? Wave front is nothing but a locus of a point which has a same phase of oscillations. So you can see there whenever a dewdrop is falling towards it, there is a wave formation which is forming in terms of certain locus. So locus of a point which has a same phase, it possesses same phase throughout, such kind of an oscillation is called as a wave front. First of all, we'll have to know about this Huygens principle, which tells that each point on the wavefront is a source of a secondary disturbance, and the secondary wavelets originate from these points, spread out in all direction with the speed of the wave. It is very clear and very direct. Each and every point on the wavefront will act as a origin for the secondary wavelet or a secondary disturbance, and each secondary disturbance which originates from these points will spread out in different direction because of which your wave spreads. That is the principle of Huygens. So the new wavefront at any later time obtained taking tangential to the surface, that is if you're taking a tangential surface in the forward direction, it is the one which is useful for the origination of the secondary wavelet. So drawing tangent to each of the primary wavelets gives the existence of the secondary wavelets. That's all about your principle. As you can see over here, these are the points on original wavelets by which we have got a secondary wavelets which are here, and for the origin of the new wavelets again a tangent is drawn, again there is a point over there, from that point again the other waves originate. That is how exactly this waves spread out. So reflection of the plane using Huygens principle. So for a reflection of a wave, you have got a plane here, name it as XY plane, to which there is from a AB is a wave from which the ray of light passes. So from B you have concept called as C, and it gets reflected with the help of this normal drawn to the surface, and from A you have another reflection, call it as D. So how the ray of light comes? This is the incident ray, reflected ray and incident ray, as well as you have a reflected ray. Both makes an angle ABC as well as this point of intersection. So this also makes certain set of angle, we name it as D. So now we know that the speed of the light whichever comes and falls here will be with respect to V1 t, well as this is also Vt, velocity with respect to time, because velocity is equal to distance by time taken. So that holds as a distance. So distance is equal to V and t. So this is the concept. So for BC, if we just consider V1 t, we can consider V2 t for the AD concept. So we know that BC is equal to V1 t and AD is also equal to V2 t. Both also V2 concepts, and there are two triangles over here, that is angle ABC and angle DCDA. Both are equal to 90 degrees, and BC AD is VT, and A as well as C are common for two triangles which is framed with respect to reflection. As a result, you can say, so this is the angle of incidence and this is the angle of refraction, angle of incidence, angle of refraction, because of which we can totally tell that the angle of incidence is equal to angle of reflection. So this holds good for the law of reflection, which we have studied in your ray optics and optical instruments. By this, we have another set of equation, that is refraction of plane wave using a Huygens principle. Again, for refraction, we have x, y component. There is a wave which falls. So you have B, A. Whenever a ray is incident to a point A, it gets refracted from rarer to denser medium towards the normal. So this is angle of incidence. This is angle of refraction. And angle is incident from B to the C on the interface of XY. Again, it's bends towards. So it is V velocity V1t, and the velocity here is V2t, wherein we join this C with the help of this, so we can name this as D. So there is an angle which is made with respect to this, which is said to be both are at 90 degrees to each other. From refraction of plane wave using Huygens principle, we will arrive at refraction laws, and that refraction law turns out to be a Snell's law. So let us just go into this. The second law, proving a second law of refraction. So now we have angle ABC is equal to 90 degree. Similarly, angle ADC is also 90 degree to each other, and we have a velocity of BC is said to be V1t, and velocity of AD is equal to V2t. So if we just consider a sine of angle theta, that is sine I, the triangle B, A as well as C. So sine I is equal to, opposite you have BC, hypotenuse is AC. So sine I is equal to, your BC is V1t, AC is just AC. AC will go there. AC sine I is equal to V1t. Again, we have sign of refraction which happens over here. So you have 90 degrees with respect to D. So triangle D, and you have A as well as C here. So this is an angle. Opposite is DC, hypotenuse is AC. So AC sine R is equal to V2t. Equating equation 1 and 2, you have AC cancels with AC, sine I by sine R is equal to T cancels with T. So we have V1 by V2, which can be, or you can even call it as N2 by N1, reciprocal. Velocity and refractive index is reciprocal of the concepts. So this holds good for the Snell's law, that is the second law of refraction by using the help of Huygens principle. And next we have resolving power. Resolving power means the ability to produce the distinctly separate images of two closely lying point objects. So if suppose the images are too very close enough, with the help of a microscope and all, we can just resolve the objects into two different or the two separate objects. So that is how what exactly is resolving power. So you have a resolving power of a microscope as well as the resolving power of a telescope as follows. So resolving power of microscope is said to be 2n sine theta divided by 1.22 lambda with respect to 1 by d is equal to concept. So telescope is nothing but you have 1 by theta is equal to d divided by 1.22 lambda. So this is the resolving power of the telescope as well as microscope equation. Next we have Brewster's law. So what is meant by a Brewster's law? The refractive index, N means is said to be refractive index of a transparent medium. It is equal to the tangent of the polarizing angle. So this is said to be the polarizing angle. So what is this polarizing angle? From where does it come? It comes from the concept called as polarization. So what is meant by polarization? It is, we have two light component coming as two sets of concepts, that is unpolarized light as well as polarized light. So unpolarized light means the one which vibrates in all direction, many direction, and the polarized light are the one which vibrates in one single direction uniformly. So converting unpolarized light to a polarized light is called as a polarization, for which there is a certain angle called as polarizing angle, that is called as a theta p. Okay, the conversion of unpolarized light to a polarized light can be done with the help of an object called as polaroids, instrument called as a polaroids. Okay, so this is what exactly the polarization is, from where we get a Brewster's angle concept, that is the refractive index of a transparent medium will be equal to the tangent of the polarizing angle. So how do you get exact this equation? That is, consider a glass to which the angle of refraction is considered. So we have a unpolarized light which is falling towards, and this is a polarized light over here getting reflected. So this is angle of refraction, this is angle. So this is a transparent medium, we can call it as a glass. This is a refractive index over here for a rarer as well as a denser medium. So we know that this is angle of incidence which makes 90 degree with respect to the refracted angle. So we have incident angle plus refracted angle is equal to 90 degree, and we know that the incident angle should be a polarizing angle to get a polarization concept. So angle of incidence is equal to theta p. Then the equation turns out to be polarizing angle plus angle of refraction is equal to 90 degree. Now angle of refraction is equal to 90 degree minus theta p is the concept. So according to Snell's law, we have sine of angle of incident to sine of angle of refraction is equal to sine of angle of incident is theta p, angle of sine of theta p divided by sine of refraction is sine of 90 degree minus theta p. 90 minus theta p is cos theta p. So sine theta p and cos theta p gives you, this is nothing but a refractive index, we get tan theta p. So this is the equation of Brewster's angle which we have got here. So that's all about your Brewster's law. So in today's class we have dealt with the wavelets, secondary wavelets formation, Huygens principle with respect to reflection and refraction, as well as your Brewster's angle polarization concept. Let us all meet in our next upcoming session with the next new chapter. Until then, have a good day. Thank you.